simple. Yesterday, some of our brains had to work in a way that kind of hurt our heads. But I'm gonna amplify what we're doing a little bit today. Not in difficulty, but just in like the little things that could maybe possibly go wrong. So on Monday we talked about domain and range. Domain lines up with which values? X, and range lines up with Y. So I'm going to expand on that, and today we're going to talk about independent and dependent variables. Independent variables are variables that are chosen values, your input, the cause. Your X values, also members of the X values are members of the domain. Domain. Independent X values, domain. Dependent variables depend upon the independent. They're your output. They're the cause, they're the effect, the Y values, and they're members of the range. So again, just another word that you can use here. X values, domain, independent variable. Y values, range, dependent variable. So today, I'm going to give you a graph and a table, and I'm going to ask for you to identify the dependent and independent variables. And to be 100% honest, on Alex, it's a drop-down menu. Victory. I don't know what's happening over there, but there's a victory over there. Okay? I can't make you a drop-down menu on this page, so we're just going to write out the answers. So let's first talk about the independent, then the dependent. Again, on Alex, it's a drop-down menu. I can't make that happen on a paper, but that'd be cool. Okay, remember, independent, input, X values, domain. On your graph, where do I find the X values? On your X-axis, yes? You are truthfully just looking to read a graph. What is the label on our X-axis? Weight of the package. So my independent variable is weight of the package. Weight of the package. Dependent variables are our Y values. Where do we find our Y values? On the Y-axis. In this case, our dependent variables are the cost to mail the package. The cost to mail the package. 110% reading a graph. Remembering independent is X, dependent is Y. Now, do you know how Alex is going to trick you? Or you're going to get it wrong? They don't always put independent on top. Sometimes they write dependent, then independent. And some of you fell for this when we were calculating the X and the Y intercepts, right? Sometimes they would put X-intercept on top. Sometimes they would put Y-intercept on top. Okay, dependent. Dependent is what letter? Y. In this problem, what is our dependent variable? Very good. The number of necklaces made. And how do I know that's my dependent? Because it says Y right next to it. Very good. Number of necklaces made is labeled as Y, which is your dependent variable. So your independent variable, or in other words, your X, is the number of hours worked. Now, on these problems on Alex, are you going to have to write anything down for me? No, it's a drop-down menu, and I know that. Okay? Dependent number of necklaces made, independent number of hours worked. Reading a graph, identifying your X's and your Y's. All right. You can then connect independent and dependent variables with graphing equations Independent variables are your x values, and dependent variables are your y values. So we're going to do some graphing again today. You're going to make a table to keep your information organized. You need at least 3 points to graph the line. You need at least 3 points to graph the line. So the equation we're graphing today is y equals negative 2/3 x minus 2. Here's the deal. You get to pick the x values. Pick the x values. You get to pick the numbers that you want to plug in to calculate what the value of y is. I'm going to tell you right now, my go-to number that is easy to work with and plug in. Every single time I'm going to plug this in. Guess what it is? 0. Every single time, I am going to pick 0. And I'm going to plug in 0. The equation I'm plugging into was negative 2/3 x minus 2. So when I plug it in, I'm going to replace x with 0. So I would have negative 2/3 times 0 minus 2. PEMDAS, order of operations. Do I multiply or subtract first? Multiply. What is negative 2/3 times 0? 0. Then I have to take 0 minus 2, which is negative 2. You just found a point on the line. What was the x? 0. What was the y? So your point would be 0, comma, negative 2. Here's the question. Somebody guide me where 0, negative 2 is on that graph. Jacob? Very good. 0, negative 2. So 0 left or right, but then we're going to go down 2. All right, Miss Hoff says I have to have 3 points. What's another number I should plug in? 1? Okay. Negative 2/3 times 1 minus 2. So I multiply negative 2/3 times 1. Negative 2/3. Then I got to subtract 2. Do you hate this? No, but you want to graph a fraction? I don't. Ugh. So how am I going to pick a number that I don't have to graph a fraction with? Gatlin?
You do 3 because the fraction is in thirds, and you could do it'd be the equivalent of negative 2.
Very good. Okay. So he said, look at your fraction. It's negative 2/3. If you multiply by 3 over 1, what happens? Your 3's cancel and become 1's, correct? So then negative 2 times 1 we can do, and we end up with a whole number. Don't forget we still have minus 2 here at the end. So we plugged in 3. Our 3's became 1, so negative 2 times 1 is negative 2 times 1 is negative 2. Then subtract 2 more, you get negative 4. So your point is 3, negative 4. Somebody guide me to 3, negative 4. Gatlin can't answer. Tori? Okay, so am I going right or left to 3? Very, yep, right, and then down 4. Okay, well that gave us 2 points, but Miss Hoff says I have to have 3. Six? Why? Very good. Make a note to yourself. Pick multiples of the denominator. That's what 3 is, right? 3, 6, 9, 12, those would all work because we're trying to cancel that denominator. So they said plug in 6. So I'd have negative 2/3 times 6 over 1 minus 2. When you take negative 2/3 times 6, what happens? 3 becomes a, 6 becomes a, so then I have to multiply negative 2 times 2 is Negative 4 minus 2 is negative 6. My point being 6, negative 6. Now, when you make those calculations and when you plot them, they should all line up nicely. Then on Alex, you'll take that line tool and you'll click any two of those dots, and your line should go through those points. If for any reason one of your points isn't on that line, that means you made a mistake. You have a quiz on Friday, right? And this is like going to guarantee you that you're going to get this right if you get all three to match up on that line. Now, if this problem was an equation like y equals 5x plus 1, it's almost a simpler problem, agreed? Does it matter what numbers you plug in here? No, because you don't have that fraction. So if it doesn't have a fraction, I'm definitely picking 0, probably 1, and 2, probably, agreed? Okay? If it's a fraction, though, pick 0. It's easy. Then pick your denominator, and then pick a multiple of your denominator. Questions on anything we did on the front here? All right, let's link back to what we did last chapter now. Owners of a recreation area are filling a small pond with water. They're adding water at a rate of 5 liters per minute, and there are 500 liters in the pond to start. Let W represent the amount of water in the pond in liters, and let T represent the number of minutes that water has been added. Write an equation relating W to T, then graph your equation using the x-axis or using the axes below. Biggest thing we have to do is we have to write an equation. The equation we like to base things off of, or we're going to base things off of, are, whoopsies, sorry, y equals mx plus b. Remind me, what does m stand for? Slope. And remember, your slope is a rate of change, or something that happens over and over. We're going to look for the words per and each. Per and each tell you that over and over that's happening. B stands for your y-intercept, which is like your starting point or a one-time fee. So we're going to have to write these equations, and we're always going to mimic y equals mx plus b. We have to replace m and b. M is our slope. B is our y-intercept. All right? So up in our problem up here, do we have the word per or each? You do. What's your slope? 5, because it says 5 liters per minute. That is an indicator per, there's your slope. Your slope is 5. Now we have to look for something that identifies as our y-intercept, or our starting point, or our one-time fee. Is there something, Gavin, that indicates that? Very good. The word to start, yes, is going to tell us that this is our y-intercept. Now we can write our equation. Replacing m and b. I would write y equals 5x plus 500. 5 is my slope. 500 is my y-intercept. They're going to count this wrong. Why? What did you say? We don't have to turn those to numbers. Nope, the equation's wrong. That? Nope. Read what it says. Write an equation. We didn't use W or T. Jacob?
I noticed something in the graph. Instead of x, it's t, and instead of y, it's w.
Do you see that? Miss Hoff still starts this way herself. I still write it with y and x because that's what my brain is ingrained to, right? Now look at your graph. T is going to take the replacement of x, and w is going to replace y. So our equation actually is,
W equals 5t plus 500.
very good, w equals 5t plus 500. Okay, now we have to graph it. We're going to make our own little xy table, except for it's not x and y, it's w and t. So Miss Hoff wants you to only have to get 2 points on this. She's fine if we only get 2. And we are going to pick numbers for t. Do I care which number you pick down here? Do I care? Pick a number. 0, I like it. Plug it in. 5 times 0 plus 500. What do I do first? Multiply. 5 times 0 is plus 500. It's 500. What's my point? 0, 500. Which we definitely could put on the graph. Now I need another point. Or another one to plug in. 1. 5 times 1 plus 500. 5 times 1 is 5 plus 500, 505. So my point is 1, 505. Okay, but I'm going to tell you, if you take your mouse, it's only going to let you put it on these perfect grid lines, yes? So you're like, how am I supposed to graph this? On Alex, there's a button. It looks like this with an X here. Okay, see this? Have you ever seen this button before? And when you click it, it pops up and it says, what point do you want to plot? So you type in 1, 505, hit plot, and it will put it on the graph for you perfectly. Now, really, it's going to be like just above this other one, right? Then you'll don't forget to take the line tool and connect the 2 dots there. I'm also going to tell you, like, sometimes this graph goes by like thousands, and you need to graph 0, 2,221, which you're not going to be able to click, right? So you're going to have to use that button and say, I need a point plotted here, Alex, do it for me. And Alex will plot it for you. Okay. Does every equation always have like y equals 7x plus 4? Does every equation have that number added or subtracted on the end? Give me an example of an equation that doesn't. Say what? I said, is there ever an equation that doesn't have like a plus or minus on the end, like a y-intercept? I mean, really, you could have this equation here, right? Y equals 8x. What is my y-intercept? Technically is 0, yes? So just like in those equations with these, sometimes your starting point is 0, 0. Don't make up a starting point just to have plus 7 on the end or plus 5 on the end. It's got to tell you something up here about where you start. Okay, it's going to give you something with the word per or each, and it's going to tell you something about where to start. If it doesn't tell you where to start, guess where you start? 0. Okay. All right. A plumber charges a flat fee of $76 to visit a home and examine a clogged drain. The plumber charges an additional $21 per hour spent fixing the drain. The total cost, C, in dollars for fixing a drain that takes H hours is given by the following. C equals 21H plus 76. So they actually give us this equation, but I just want to show you. 21 is your slope because $21 per hour. Per hour. 76 is your y-intercept. Key phrase, flat fee. They charge you $76 no matter what. I could be there 2 minutes and you're paying $76. Okay? So they say, what's the total cost for fixing a drain that takes 6 hours? What do you think, Lane? Very good, because it says 6 hours, right? So really we need to take our equation, and our h equals 6. So our equation c equals 21h plus 76. We no longer need h, we need 6. So 21 times 6 plus 76. What do I do first? Multiply 21 times 6. 126. Plus 76 is 202. Label on 202 would be dollars. For 6 hours, it's going to take $202. Okay, different scenario. What if the plumber charges a total of $307? How many hours did he spend fixing the drain, Thad?
So start off by writing it out. Know what C is. Do like total cost. So the total is 370, right? 307 equals 21 each. If you don't know how many hours it took yet, and then you still add on the flat fee of 76.
Perfect. This time they told us the total, so this time C is 307. Nicely done. Bring back some chapter 2 stuff here. We have to solve for H. What are we going to do first? Subtract 76 to the other side. 307 minus 76. 231 equals 21H. Then divide by 21. H equals 11. Yes? Anybody else? Yeah? So 11 hours. 11 hours. So we're really starting to see like grouping everything that we've done, right? Chapter 2, bringing back solving equations, identifying rates and change and your y-intercept and putting those two together. On your Alex assignment, are you going to have anything to write down for these? No, but the rest of this has quite a bit of work to show, yes? Okay, so you have the graph or grid paper in the back if you want that. Use your own paper if you want your own paper. Log into Alex and get started. I will be around to help.
I am not. I have